Hi! Recently I tried a method for making PCBs using a 3D printer without any chemicals that I think might replace the way I make prototypes. I'm going to use both an FDM printer and a resin printer to compare the results. At first, I thought about experimenting with the conductive filament I used to make the buttons for my silicone pad for playing emulators on a phone, but the limitations are too many. By the way, if you'd like to support videos like this, or this project in particular, it would really help if you left feedback in the comments or subscribe to the channel. Anyway, let's continue. I will only use open source software, so anyone can replicate this process. Specifically Inkscape and FreeCAD. Let's start with Inkscape. For this example, I'm going to replicate an existing circuit, but you can also design your own. First, we create the terminals of the circuit traces using the circle and the square tools. Then we use the pen tool to draw the traces themselves. You can hold Ctrl to keep the lines perfectly straight. Once everything is drawn, we select all the parts and press Ctrl+ to combine them into a single shape. Next, using a different color, we draw the circles that will become the drill holes. A diameter of 1.5 mm worked well for me. After that, we combine all the holes into a single shape by selecting them and pressing Ctrl+ again. Then we select the PCB traces first, hold Shift, select the holes and press Ctrl- to subtract them. Finally, we draw the outline of the PCB and save the project as an SVG file. Now we move to FreeCAD. We import the file we just saved as a geometry, and all the parts of the PCB will appear. We need to convert each part into a sketch. To do that, we go to the Draft workbench, select each part one by one, and click the Draft to Sketch button. Then we hide everything except the sketches by selecting the objects and pressing the spacebar. Next, we select the PCB traces and merge them into a single sketch. Go to the Part workbench and click the Union button. Then we do the same thing with the holes. Now we need to give volume to each part. First, select the PCB traces and click Extrude. In this case 1 mm is enough. Then we extrude the holes with a height of 10 mm. Finally, we extrude the PCB body itself. I used 3 mm, but you can experiment with different thicknesses. Now we move the PCB body along the Z-axis so the traces overlap slightly with it. In my case, I used the thickness of a single print layer, 0.2 mm. Select the PCB body first, then the traces and press Cut. Next, move the PCB body again along the Z-axis so the holes go all the way through. Select the PCB first, then the holes and press Cut again. That's it, the model is finished. Now we just export it as an STL file. In the FDM printer slicer, I'm only adding a brim to avoid warping and lowering the print speed to preserve the small details. For the resin printer, I'm not doing anything special. And this is the result. Obviously the resin print has better detail, but both versions came out well and are perfectly usable. Now we place a piece of copper tape over the entire circuit area. Then, using a soft tool, we press the tape into the PCB traces to improve adhesion. I'm using a tool from a Play-Doh set, but something like a pen would work as well. Once you're happy with the result, it's time to sand. Place the PCB on sandpaper, in this case 400 grit, and sand it in circular motions with firm pressure. This step can take a few minutes, but applying a bit of pressure speeds things up a lot. Once only the copper traces remain, clean the board. This is also a good moment to check for any shorts. Now you can make the holes using a needle or even the leads of an electronic component. I recommend doing it from the top side so you don't leave the traces. I think the results are very good with both methods, but the real question is whether they can be soldered. Honestly, soldering works much better than I expected. I just take the process a bit more slowly and avoid leaving the soldering iron on the PCB for too long. The resin PCB might be slightly more resistant to heat, but both options are perfectly usable. As I said at the beginning, I think this might become my new favorite way to make quick PCBs at home, especially if you have kids around, since you avoid using and storing potentially dangerous chemicals. That's it for today. If you liked the video, or if you want to support my silicon phone gamepad project, it would really help if you shared your experiences in the comments or subscribe to the channel. Thanks for watching.